This is just a short version of the video designed for those of you who are awesome at graphing and don't want to waste a lot of time having me go through example problems. Essentially, this one boils down to the fact that the slopes of lines that are parallel have the same slope, and the slopes of lines that are perpendicular are opposite reciprocals. We did cover this once briefly earlier on. If you were really good at the reflections across lines in the coordinate plane, when those lines weren't the four basic ones that we had coordinate notation for, then you'll be great. Otherwise, you may want to watch the long form of this video. So again, slope is rise over run. You need to know how to graph equations, do y-intercept form of an equation, as well as know the point slope form. We'll note here that when we have, I'll go back. When we have parallel lines, they have the same slope. I mentioned that. The weird one is perpendicular lines. So what is the relationship between perpendicular lines? Well, there's an example right here. These guys are perpendicular. And we can calculate the slope of both. This one has a slope of negative 1/3. This one has a slope of positive 3. So as it turns out, they're what's called opposite reciprocals. So opposite reciprocals, opposite being we throw a negative on there, and reciprocals meaning essentially, there's two ways to think of it. One is that we switch the numerator and denominator. So it becomes 3 over 1 from 1 over 3. If you take the reciprocal again, you go back to 1 over 3. Another way to think of it is you can take whatever value that is and divide 1 by it. So 1 divided by 1/3, or 3 divided by 1/3, something like that. Or 1 divided by 3, something like that. So two ways to think of that, but reciprocals, we should be able to calculate those. So yeah, sometimes the book really likes these forms of questions where they ask us to write the equation for a line that is similar to one of their lines in some way, so either parallel or perpendicular, but it goes through a different point. So for example, this one asks for a line that is parallel to this line, but passes through this point. So again, you need to know, and it's probably good to memorize, the point slope form, because all you have to do is write down the point slope form, and then you take, if it's parallel, you take the slope of this line, right, that you're going parallel to. If they're asking for something that's perpendicular, you take the opposite reciprocal. And then you take the coordinates here, you plug them in, and you simplify and solve for y. So those are parallel lines. If we do a perpendicular one, if we do a perpendicular one, again, you don't take this if we want a line that's perpendicular, you take the opposite reciprocal. So in this case, the slope would be not negative, but it would be positive. And instead of being 2 over 5, it would be 5 over 2. And then again, we can take these values, plug this and this into our point slope form equation. And in this case, blah, 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 blah. There you go, have some notes. Our point slope form equation. And then we simplify into that y-intercept form. I'll do 2 examples real quick. Let's see. So I'll do example 4 here. It asks for a line parallel to y equals negative x. So in this case, the slope is negative 1. And then I write out my equation here. So point slope form is y minus y1 equals m times x minus x1. Memorize that. I can plug in, that's my x1 and y1. This is my m, and I just straight plug it in. So y minus 2.5 equals negative 1. I can distribute later, x minus 5. Y minus 2.5 equals negative 1 times x is negative x. Negative 1 times negative 5 is positive 5 plus 5. Y equals negative x plus 7.5. So that's that one. And then I'll do an example with the perpendicular lines. I'll do number 7 here. It asks for the line perpendicular to this line that passes through this point. So the slope for this guy isn't going to be 3 over 2 because I want it to be perpendicular to that slope. So it's going to be negative 2 over 3. And then here's my, those are the values I'm going to use for my point slope form. Y minus y1 equals m times x minus x1. Whoops, I can plug in my numbers. It's all ugly. That works. I can plug those in. So y plus 1, double negative, equal to this thing, negative 3 x minus, and then this x is 3. Y plus equals double negative here again. So it's a positive. 3's cancel. I'm just left with 2. And then finally, y equals negative 2 over 3x, subtract 1, so y plus 1. Cool. That's it. That's all I got. Those are my 2 examples. Shorter video though.